Okay, so welcome everyone to this third Astro-Journey webinar. I'm very pleased to be there. And so for those of you who haven't seen the previous webinar, Astro-Journey is a European project. You can go, of course, to our website, astrojourneys.eu. And the goal is to see how teachers can create a long-term project, like a few months project, using the resources from our partners. The first webinar was about Astro-Journey in general, and the second webinar was about robotic telescopes, which is one of the tools of Astro-Journey. And this webinar is about Human Orrery, that is another tool proposed by our partners. So I'm Emmanuel Roland. So I'm a researcher in physics education in the University of Cergy. And we have also Clément. So Clément, who is also a researcher in physics education in the same university. And we are both working and doing research with the Human Orrery. So, of course, if you have any questions during the presentation, please do not hesitate to interrupt me. Okay. So I send a short survey on Zoom just to know not who you are, but how much do you know? Sorry, how much do you know about the orrery? So unfortunately, I cannot really see it, so I will see it later on. But okay, so I will do this presentation in 3 steps. So first, what is orrery and what is a human orrery? For those of you who never heard about it. Then we'll discuss the content that we can learn and teach with the orrery. And last, the things how to get your own orrery, how to build an orrery in your school. So that's clearly the goal of this webinar is to encourage you to create an orrery in your school. So the first two parts will be to tell you why it's very nice stuff to do. And the third one is to prove that it is not very complex to create an orrery in your school. Okay, so to start with, you might know already about mechanical orrery that are very famous. So mechanical orrery, I have 3 pictures here. That's a mechanical tool where you observe the movement of the planets in a heliocentric frame. So you have the sun at the center and all planets moving around. Of course, the size of planets is at a different scale than the distance in any orrery. If you had the same scale, then you will not see the planets. And some orreries, some mechanical orreries, include moons. So like the one on the top, you have moons around Jupiter. And this one, you can see the moon around Earth. And this one has no moons. And of course, again, if you have moon, you need to use a different distance scale, because otherwise the moon is at the same place as the planet. Okay, if you use the same distance scale for the solar system and for the planet and moon system. And in most cases, mechanical orreries use circular orbits. I believe there are a few of them who do the ellipse, but they need a very complex mechanical system. So in most cases, mechanical orreries are with circular orbits. So what is the difference with a human orrery now? So the goal is the same, to represent the movement of planets in a heliocentric frame. But here, the learners become the sun, planets, and comets. So in the video on the bottom, you see dancer. So they are twirling dancer, so from Turkey. So it's also an artistic activity. And in the center, you have the sun, and then with different colors, you have Mercury, Venus, Earth, and you have also the asteroids belt. You have Jupiter, I think, in this one. And on the top of the screen here, you see, you saw at the beginning some students who were walking, and here you see a dancer who is following the path of a comet, of an exoplanet that is moving around a star in another system. So the main idea of Human Orrery, first learners become the sun, and also it's easier and it's very logical that we can follow the Keplerian orbits. So when you use a Human Orrery, you don't have circular orbits, you have Keplerian orbits. You have one distance scale. Of course, there is no size, so we just don't put size. We just put a drawing. You can see here a picture of a planet, but it's not at all on scale. And there is no moon. That's a choice. We decided not to show the moon. So we don't have two distance scales. We have just one distance scale. Okay? So that's the idea of the Human Orrery. So in terms in more scientific wording, Human Orrery is a spatial temporal map. So we might call this a chronophotography. So here you have to be careful because you see some points because it's a chronophotography. So at regular time intervals, you have the position of the planets or the comets. But this is intended to represent a continuous movement of objects. So you can see on the top here, so I start the movie again. This is from Stellarium, and you see planets are moving continuously, and same the dancers, they are moving continuously. So even though we have discrete positions, the goal is to describe a continuous movement along the orbit. So what do we have? We have the sun and the planets. Usually we stop at Mars. When you have a large space, you can go up to Jupiter or even more. We will see that at the end. We have the asteroid belt in most orreries and one comet. So the goal here is to have the main type of objects in the solar system: one star, planet, one comet, and the asteroid belt. Then we have a time scale. So here it's written 16 days. So this is a duration between two consecutive numbers. Like for the orbit of Earth, if you want to go from one position to the next, okay, Earth takes 16 terrestrial days, but when you will move on the orrery, you will take, for example, 1 second. So this is a time scale that relates the real time to the time in the choreography. And of course, it's the same for Venus and Mars. If you go from one number to the next, it takes 16 terrestrial days for the real objects. In the case of the comet, it doesn't matter so much, but we have here numbers that are 3 by 3. So you need 3 steps to go from one point to the next. This is a kind of a detail, but just to tell you that you don't need to have every orbit with the same duration between 2 points, 2 positions, but you need the same durations between 2 numbers to go from one number to the next number. Then you have number 0, where you have the pictures of the planets. This is the position of the planets at a given starting date. So in the map, you must have the starting date somewhere. It is written somewhere to tell the user, okay, now if you put yourself in the position 0, this is the exact position of planets at this specific date. So I say the exact position, and this is very important. The position you have here are the exact position. They are that's the exact position of all the objects during 1 year, during one revolution. So if you start with Earth at the starting date, and you observe Earth moving around the sun during one terrestrial year, it follows exactly the position. After one revolution, you might have some shift. It's a bit of a detail, so I will not go further on that, but just remember that because 1 year is not a multiple of 16 days, so of course there are some shifts. But if you forget about that, you can follow the position of all those objects here as they orbit around the sun. Okay. And of course, this is a spatial temporal map. So we have the time scale and we have the distance scale. Okay. So you can use this as a map to measure and convert the distance from the map to the real distance. And you can convert the duration from the choreography to the real duration. Okay. So now we'll go to the content that you can learn, which is the most interesting. And to help you understand better, we shall make a little game. So be careful. You have to take your screen, enlarge the window from Zoom, and then you will make the game as the students are doing. So Clément will make the role of the teacher. So Clément, you will give the reason.
Yeah, just before you can zoom in the Orrery by using at the name, there is something written like screen of Emmanuel Roland. On the right, you have three dots, and then if you click on it, you can make a zoom of his own windows around, for example, 150. Then you can see better because it's a bit smaller otherwise.
So we will do it, Clément and I, and then you will do it, okay? So we'll show you. Do you see my mouse? I guess you see my mouse, yeah. Okay. So Clément, I'm ready.
Okay. 1, 2, 3. Tap, 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 tap.
Okay, thank you. So you could see I try to do it continuously, and every time Clément says tap, I have to be at the next position. So everybody do it, I will do it at the same time. But you have to open your microphone if there is not too much noise around you. And when you believe that you have done one Earth year, everyone shout stop.
You can select. You can try to be on another planet too if you want.
Not yet.
Not yet. Okay, sorry.
No, right now everybody is doing Earth.
Okay,
it is written here on the top.
We start at 3. 1, 2, 3. Tap, 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 tap.
So nobody has done 1 year?
Yes, me a lot.
Yeah.
I am on Mercury.
No, you have to be on Earth. Everyone on Earth.
Okay, sorry.
Doesn't matter. Okay, so what we are doing here, you can do it with your class. You can print the orrery and do it with your finger. You can also have, and we will talk about this afterwards, but you can have the big one and walk on it, or you can have a small one and move with your finger. So let's try just to be sure everybody understood before we move on. Let's go maybe again to Earth, just to be sure. And everybody say stop when you have finalized 1 year on Earth. Okay, Clément.
Ready? 1, 2, 3. Tap, 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 tap,
Stop.
tap.
I
Ah.
heard one stop. Okay, I hope everybody understood that when you have done one revolution, this is 1 year. But now, the interesting point here is that we have different planets. And the definition of 1 year is to make one revolution. So just to be sure that everybody got the game. So you're going to play the role. So be careful. If your first name starts with a letter from A to G, you shall be Venus. If your first name starts from H to N, you shall be Earth, and Mars are the other one. I hope, like for example, Isadora, do you know which planet you have to play? Isadora.
Sorry, can you?
Isadora, which
Yes.
planet do you have to play?
Mercury?
So your name starts with I or with
I.
I. So I is between H and N.
A, B, C, D.
G.
Yeah,
F,
Earth.
G,
I
B,
think it's
G,
Earth.
E. F,
So let me tell you
G,
again. You are Isabella, so it's between H and N, so you will play Earth. And Raquel, are you there? Raquel, I don't know if Raquel is your name or if it's your nickname on Zoom. We'll see. And Shitra Singh, you should play the role of Venus.
Hi.
Okay?
Okay.
Okay. We'll
I'm
see.
Earth.
Huh?
I'm the Earth.
You're the Earth?
Yes.
Ah, Raquel is here. So which planet do you play, Raquel? So Isadora, you will be Earth. Benedict, you will be Venus. And Raquel, you will be Mars. Okay, let's try. And then we'll move on. Okay, so every time you have finished 1 year, you say the name of your planet. So 1 year is one revolution. Okay? Allez, let's try. So I play the role of the planet. Clément, go on.
1, 2, 3. Tap, 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 tap,
Venus.
tap, 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 tap,
Earth.
Earth.
tap,
Good.
tap, 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 tap,
Venus.
tap, 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 tap,
Earth.
tap, 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 tap.
And Mars should be there somewhere.
Oui.
Normally, Mars should have done one turn. Okay, very nice. So, just to make you feel what is going on, we shall do it for the comet. So the comet is very hard, so be careful. So we won't do the real one. Every time Clément say tap, we go to the next disc. And normally we should wait 3 steps, but
yeah, okay.
no, to make it faster. So every time Clément say tap, we shall be at the next position, okay? Are you ready?
1, 2, 3. Tap, 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 tap.
Okay,
tap,
beautiful.
tap.
Thank you, Clément, for this beautiful music.
Yeah,
So,
just about that, it's really more comfortable if you use a metronome, but
yeah.
could be somewhere a bit too distant from the children, and usually you just use a clap.
Yeah.
I should
have
have
a
done that
question.
more.
Yeah.
For
Benedict?
the comet, it's not 3 top
Yeah, it
for
is, it is, it is. But just to make it easier,
transportation?
yeah,
Oh,
you're right. You're right, but just to make it easier for everyone, this is kind of a detail for the choreography. So just for today, we made it like one by one. Okay.
oh.
But what you might have felt, not sure, so you can try later, is that here you're going slowly and then you have to increase your speed as you go towards the sun and decrease your speed as you move away from the sun, which is logical. But the point is, either with your finger or with your body, the students, your students, will feel the variation of velocity as they move along the comet, and they might feel the difference of velocity as they go from one planet to the next. Mars is going much slower than Mercury. So the idea here is to feel, to perceive with our body the difference of speed, the difference of distance, and the difference of duration. That's not an easy task, but the advantage is that if your students feel those abstract notions, they will understand much better. Okay, so this is related also to a global cognitive science field, which is called embodied cognition, that explain that all our abstract understanding should be based on a perceptual activities. And that's what we propose here. Okay, so now you have seen what we do with our body when we use the orrery. And from that, what can we learn? So I will first go to the connection between orrery and what is called the big ideas in astronomy. So if you don't know about it, it's a very nice booklet that gives the basic things we should know about astronomy. So it's not about curricula, it's about astronomy. And then I'll come back to the curriculum. So the big ideas, so what do we have when we use the orrery? So obviously we have the different type of objects. One advantage compared to a classic lecture about astronomy in school is that we don't talk only about planets, but then you can talk about comets, you can talk about asteroids, you can talk about meteorites. Because, okay, you can talk about every different type of object through this image. You might also discuss about this question of very important question of is the sun or Earth at the center of the solar system? So it's one way to talk about this question. And something very nice. So as we discussed, the orrery is based on duration and timekeeping knowledge. So through the experience of the orrery, we can talk about the day and night. If one student stay in a disk and move around itself, he will perceive the fact that the sun is in front of him or backwards of him. So he can perceive in a very efficient way the alternation of day and night. And as we did before, he can perceive also what a year means. And this has been done now in many, many classrooms from very young age until till the end of school to discuss the different units of year. You can also discuss about the months by asking how many months do we have in 1 year, etc. Okay, so yeah, and so you can discuss also about scales. So the fact that time and distance scale in astronomy are a lot larger than the ones we use in our daily life. This is something it will be nice if most people know about what is the range of time and the range of distance in the solar system. And the last more not funny but more little case to discuss about meteorites, about shooting stars. You might know that we see meteor showers, so we see shooting stars when the orbit of Earth passes through the orbit of a comet. So we can discuss about the origin of the meteor shower. So why does that happen every year at the same date? That's because it is the exact day when Earth passes through the orbit of the comet. Okay, so this is kind of the literacy of astronomy that you can learn or you can teach through the use of the orrery. But we are more interested here in curriculum-wise, meaning that our goal is not only to teach or to learn astronomy. Our goal is to use the orrery as an astronomical context to learn about a lot of things in the curriculum. So I put here some ideas. Of course, you can relate that to art and sport through the choreography. You can relate that to the timing, the rhythm. You can change the rhythm and you can see what it creates in yourself. You can do a very fluid choreography or a discrete choreography. So this is related to arts and sport. And in a few minutes, we'll discuss about how to create an orrery. And this might be done by your colleagues in art, the art teacher. So in physics, that's clear that we have all the idea of units of time and distance, and we have kinematics and dynamics. That's the main subject when you use the orrery, is to discuss about kinematics and dynamics, but in a more motivating context, which is the movement of objects in the solar system. It's better than just a bike that is following a trail in the city, which is the usual case we use when we discuss about kinematics. We have someone in the train, we have a cow who looks at the train, and here you have a planet that is moving around the sun. It might create more motivation in your classroom. There is also the context of geology, so different type of planets, question of habitable zones, exoplanets. So this is something that can be discussed and can be, used as an interdisciplinary connection between physics and geology. And I found out that when we use this orrery in schools, actually mathematics is one of the most powerful contexts to be used, because you have the geometry. Is it a circle or is it an ellipse? What is a circle? How can you prove if it is a circle or not? And then you can extend that to what is an ellipse. You have all the relations in astronomy that are actually power-law relations. Most relations are power-law, like the Kepler relations. So it allows you to make measurements, to compare the measurements to a power-law relation. So to discuss what is a power-law, how can I check if a relation between two numbers is a power-law or not? And if you work with the time and distance scales, then you can have a lot of activities about the power of tens, which is more famous to compute the distance between each planet. Then you use power of tens to go from astronomical units to kilometer and so on. So you see, with just one tool, you have a lot of interdisciplinarity. Benedict?
I think for mathematics, you can add scales.
Yeah, scales. Yeah, you're right. Scales. Scales is okay. Yeah, you're right. Yeah, scales is really a mathematical items. You mean? Yeah.
Yes, because I am working on my Astro-Journey now in these days, and then for the mathematics teacher, he will do by himself all about the scales.
Yeah.
After the solar system, and I need him for the scales in mathematics.
Okay.
I
Yeah,
don't do that by myself because it's very mathematic.
of course. Yes,
So
that's a
I
very
think you can
important.
add that not in physics but in mathematics.
Yeah, and it's a very important point that you are telling, Benedict, is that Astro-Journey, one of the goals is to create interdisciplinarity, so connections between teachers and subjects. And by using a tool like this one, it really get it easier. It really eases the process to do interdisciplinarity, because you do only one context, but you need math and you need science to finalize the activity. So I will just show you a kind of a typical sequence, meaning that when we talked about the orrery, we thought, okay, what can we do with that? So we proposed a series of session, yeah. And here you see it's everything we propose in this column can be done for any class beyond 6 years old. So you can start at very young age. But then, yeah, there are some stuff we believe you can do only for above 11 years old and then only above 15 years old. So typically, the suggestion is to start, of course, it's not a suggestion. The first session is really to discover the human orrery. So as Benedict says, at a younger age, you discover the object of the solar system, you walk along the numbers, so you do some numeracy, and you try to do the best choreography as possible. So like a continuous choreography. If you work with older students, you can talk about scales already. What is the meaning of scales? How can you use them? Then the suggestion is to start with time. So really to disentangle time and distance. So first you do a session about time. And I don't know why I put referential frames here, sorry. So you can do the timing of day and night, months and seasons. You can do the birthday. So how many birthday I have if I'm in a different planet, and then you work on years.
Just, Emmanuel, to answer your question about referential frames is to speak about who is turning around who. So just, is it the Earth who is turning around the Sun or the opposite? Which depends on the referential frame. So it's a way to introduce it.
Right. So when you talk about day and night, actually for older students, you can talk about referential frames indeed, to explain the meaning of day and night, and also the meaning of years. Thank you. So once the time is clear, you can go to the distance, to the geometry. So for example, you can work on the shape of orbits. Just to be clear, that everybody is aware of time, the separation between time and distance. And once this is done, you can go to the speed. So it's really an advice, because we realized that in many classes, the question of speed, time, duration, so this three parameter relation is a very complex one. So if you use the orrery too fast, if you go directly to speed, then you will get lost. So the suggestion is to really disentangle again the discussion about time, discussion about distance, and then you bring both together and you have discussion about the speed. And if you, again, with older students, you can go up to a proportionality relation. Is it proportional, like the distance traveled? Is it proportional to the duration of the trip? This is the case for the planets, but it's not the case for the comet, because speed is varying for the comet. And for even older students, you can talk about acceleration and force of gravity. So you can go quite far, and the fact that you have a comet helps to go further than if you had only planets where the orbit is almost circular, the speed doesn't vary much. So it's less interesting. Just, okay. And then again, further, you can work on the Kepler's relation. So even with younger students, you can still work on the measurement of area. So you have the second relation of Kepler that can help for that. And otherwise, for older students, you can go for the 3 Kepler relations and have the power of 10 and the uncertainties in the measurement and the mass of the sun and so on. So when I have done all those steps, I have covered kinematics, dynamics, power of 10, scales, and that's all. And uncertainties in measurement. So it's already a lot, only with this little tool. And again, just to emphasize that the students will embody the movement. So it's not only that they will think about speed and force, they will feel the force and the speed. And then we have 2 little things, like they can work on shooting star, just to, because it's quite a fun observation, and the retrogradation of Mars, that I'm not going to present now, but it's a very famous observation in astronomy that is related to referential frames. So if you need more, you can ask us later. Okay, so time is going faster. Oui, Clément?
I just wanted to add that about this table, that when you have a blank case, doesn't mean that you cannot do anything. Just if it's the first one, it means that we think it's too early to introduce.
Yeah,
But
it's above.
for the ones 15, 18, it means that you can always do the same things. So you will make the discovery, whatever, but it's not really an object of learning for them normally. And second things, as you discovered about the year, for example, the unit of year, to do it, we do it right now for an experiment with grade 1, so 6 years old, so really young kids. And it's difficult, but it's really interesting because we give them some meanings about what is this civil year, what means a year that we use in the everyday. That has a meaning, a physical meaning. And this is something, I guess, is really interesting to still do, even when you are with kids of 11, 15, even with 15 years old. That they really understand that the things that you use every day, that means that. So it's really to give some meanings more about it.
Benedict?
I didn't really understood about the reference frames with the day, night, months, and seasons. Which kind of activity you do concrètement?
It's mostly for day and night. The main idea, it's a very complex thing, but the main idea is if you look at the sky, alternation of day and night means the sun is moving around Earth. Okay, the sun moves around Earth when I look at the sky. So in the referential frame of Earth, it is the sun that makes one round in 24 hours. But the society and the science tell us, no, that's Earth who is moving around itself and the sun doesn't move. Okay? Yeah. So we have like a conflict here. Is it the Earth? Is it the sun that is moving in 24 hours? Or is it Earth that is moving around itself in 24 hours? If you ask this question, almost everyone will tell, no, the truth is that the sun doesn't move and Earth rotates around itself. So what we claim, and you can show that with the Human Orrery, is that the truth is that it depends on who observes. And science tells that. And Galileo said that. He said, if you observe from Earth, so from the terrestrial frame, the sun is moving around in 24 hours. If you observe from above, so in the heliocentric frame, then the sun is fixed and Earth is moving around itself.
Okay. Because I was looking for an activity about that. But before to introduce the Orrery,
so the activity will be it's a very simple one. You just have one light. Yeah, it's one light, and you turn around yourself. You see the light in front, on the left, in the back, on the right, and then you do the same with the light that move around you, and you see exactly the same thing. So you change the referential frame. Okay. Okay, let's keep going because I have to explain how to build a Human Orrery. Okay, so just to tell you, if you want to get ready, so if you want to do those sessions as we described, you can go to the website of Astro-Journeys. There will soon be a direct link to the PDF of each session in a few weeks or months, but very soon. And in the meantime, you can go to the link to the Aristarchus project, where you get the learning sequences, but you also get information like a booklet about what does that mean, this embodied cognition? What does that mean that the student perceives stuff? Okay, so there is some kind of theoretical descriptions. And you have a link to the website to create your orrery. And that's what I'm going to present now. Okay, so how to get your own orrery? So you can send me a mail, I will send you the PDF. That's that's the easy way. And then you go to a printer, and the printer will print the PDF on a large scale. That's a very easy way, but boring way. You send me a mail, I send you the PDF, you send it to a printer. Or if you want, I can send it to my printer, and he will send it to your school. Okay, so that's
you have to pay. You have to pay a little bit.
You have to pay like 200 euros, basically.
No.
No?
More like
Okay.
50. But not so much. But
yeah, let's say 300. Okay. Okay. So, but that's not the best way. The best way is to have your student do the orrery and to have yourself do the design of your orrery. So to do that, you have this beautiful website. Okay. So you click there or you type this. The registration is free, but you have to register. And there is an online tutorial to use it. You will have to sign up, provide some information. And here, as a moderator, you just choose me. Okay. And then I will validate your registration. Please do not forget your password because this is the limitation of this website. If you forget your password, you have to send me a mail so that I can create a new one. Okay. And this website may be a little bit unstable, so keep patient. Okay. Otherwise, it's a very nice website. So once you register, you sign up, you get here. So you can create your own orreries. It can be in English, in French, in German, and in Greek, the website. So you have 5 boxes to get that, to get the orrery. So you can choose a date you want. So let's say you have a lecture, 13th of February, 2027, with your class. You can create a PDF with the position 0 at this date. It might be nice because then you give it to your students and they have the position of the planet at this exact date, the date of your lecture, which is nice. You can change the time unit, so the duration between 2 points, the duration to go from one point to the next. Usually we take 16 days, but some people like to take 1/24 of a year, which is nice because then Earth come exactly to number 0 after 1 year, which is fine. So that's a detail, but you can play with that. And then the next thing, you can choose the objects that you want to add. Okay, so you can add, insert objects, you can remove objects, you can change the duration between 2 points. That's what Benedict said at some point. For Enke, we put one position every 3 steps. Okay, you cannot add logos. Okay, so the logos of the association FHOU is mandatory, and IREM is also an institution that created this website, so this is mandatory. You can add legends, so you can add the time you need, the observation date, you can add another legend that you like, you can add the distance scale. And after all this is done, you get those files. So you get the PDF of the orrery, with numbers or without numbers. That's as you wish. You might want to have a drawing without numbers for any reason. And then you get those templates. So meaning that for each object in the orrery, you get one page with only the sun and the position along the orbit. So of course, the distance scale is very different. For Mercury, this is one astronomical unit. So Mercury, the radius of Mercury is about half an astronomical unit. Okay. But for Earth, astronomical unit is a radius, of course. Okay, so be careful. Each template has a different distance scale. So why do we need that? We need that to help you create and draw your own orrery in the school courtyard. So this is very nice way, very engaging way. So I showed you some very nice pictures. So first you have to choose where you want to do your orrery. If you have an observatory near your school, you can do that. So this one is the Armagh Observatory in Ireland. This is the first historical human orrery, so a beautiful one. You have one in India in a school, one in Paris in a museum. And here is these two French schools who did it with their students, and this one is a German school who also did it with their students. So you have to choose your place. The biggest, the better. The bigger, the better. And then here are the steps to follow. So first, you have to decide on the final distance scale. So you have your printed here orrery, the printed one with a small distance scale, like a few centimeters for one astronomical unit. And with your class, you decide how big should be your final human orrery. In most cases, we take 1 meter for one astronomical unit because this is simple stuff to do. But if you want a bigger one, if you want Mercury to be not too close to the sun, you can choose a larger distance scale if you can. So you choose that and then you draw in your court. You check that the complete human orrery will fit in the place, in the area that you decided. And then you put the sun where it should be. So this is a mathematical activity. I want the sun to be here. Where should it be in my court? So there are different ways to do it. You can make a square here and check where should be the square there. And then how do I find the center of a square? You can ask your math colleagues, or if you are yourself a math teacher, you will know how to find the center of a square and how to draw a square. This is not so simple. And then you also have to decide the direction, because when you do a map, you always have a direction. So this is a very special direction called the vernal direction. I let you check on Wikipedia what it means. But this is an astronomical direction. Usually, we put it towards the south. But this is not at all mandatory, because south doesn't mean anything when you talk about... south doesn't mean anything when you talk about astronomy. South means something on Earth, not in the astronomical point of view. So just you can choose south to choose something. Okay, and now you have the sun, you have the direction. So now you take your template for each object, one by one. You take your template here. So we have the sun and we have this direction that we have chosen. And first you measure the distance scale here in your template. So you write 1 astronomical unit is that number of centimeter on my template. So why do we do that? Because now you will measure the distance from the sun to the position for each position. So maybe I should say that first. What we're going to do is a very direct homothétie, so enlargement of the template. That's why it's not so complex. We need to do, for each point, we need to make an enlargement of the template. We cannot do something else because it's impossible to find out the position by any numerical equations or whatever. You cannot do that in a class. So what we do, we provide you with the positions for each object and the position along the orbit for one revolution. So now you have to work a disk or position by position. You compute the distance from the sun to the position here, and you convert in the distance for your orrery. So my advice is to start with the template, convert in astronomical unit with the scale here, and then convert to the distance in your orrery with the scale that you have decided.
Just you put your template on the center of the sun.
That's the next one. That's the next one. First, you take your template, you work in the class, and you work point by point. Then the next step is indeed to put your template where it should be at the end. Okay, and then what you simply need to do is to do this. So you just you just start from the sun, go to the disk, to the position in your template, continue your line. So you can use a laser or a rope or whatever. And then you in the previous step, you had converted the distance. So you know where to mark the position here. So it's not too complex when you are close to the sun, but when you are far away from the sun, it starts to be very complex, because if you move a little bit your rope, then everything changes. So this is an activity where you have to be very patient and cautious, not to go too fast. So it's nice also to work, not with a full class like 30 students. It's more an activity for small groups. So something you do, I mean, the building of the orrery cannot be done with a class, with a full class, because you need to do it slowly.
And how long time does it take when you are with students?
So the idea will be to do this part in a class in 1 hour. So you divide your class in groups. Each group take one object and a few positions. So in 1 hour with a full class, you can find out, you can fill this table for all the objects. Okay. Yeah, okay. And then I would suggest to take your time and to do it slowly, like every week you do one orbit.
Okay.
So for the first orbit of Mercury and Venus, it will be done in 1 hour because there are very few points. But when you do it for Encke, for the comet here, it might take more than 1 hour. So do it slowly. I have a colleague. Okay, I don't have it here, but there is a class in France. They took 3 years, little by little, and now they are doing Uranus. So they are drawing the orbit of Uranus. Okay. So then they don't do it with the students; they do it with a company. But okay.
Because so just on the middle, there are usually other students of all the college. So you have to do that in the night, for example.
No, not in the night, like during noon, during lunch, or at 4 o'clock. When I mean, you have to
at the end of the day, because at noon
maybe at the end of the day,
is on the center. Yeah, not just for.
Yeah. It's better for a club or a special activity. I mean, but this is very engaging for the class and for the students. And just to finish on that, when you are done, a nice way to check that it's fine is to walk on it and to check that you are walking smoothly, so that you don't do like a big step and then a very small step and then a big step, because it's not so easy to do. And if one point is wrong, either you redo it or you put it by hand, just so that it makes it Nice. Don't expect to have a drawing as beautiful as the PDF that you get from the website. Of course, your drawing, there will be some mistakes, points that are not exactly where they should be. So later on, if you want to do measurement, do not do the measurement here. I mean, on the one drawn in your courtyard. Or if you do so, just be aware that there will be more uncertainties. There will be more errors. Okay. So the goal here is more to have a beautiful object in your courtyard. And if you want to work, if you want to have a very accurate one, do it with a printed orrery. Okay, but with this one that you draw on your courtyard, then you can perceive the movement, you can feel the variation of speed. That's fine. Everything is fine. Just you cannot do accurate measurement with that. Okay, and just to tell you also how to check, you can check that is this really an ellipse? There are some way the math teachers know how to check that this looks like an ellipse. So you can check with your students if they succeeded to draw an ellipse or not. Okay. So my proposition is to make it an adventure for the whole school, because if it takes 3 years, you can take many different classes and all of them will draw one orbit, little by little. And every schools who have done it, it really created an adventure for the school. Here you see some pictures, nice pictures. And here, this is all the orreries up to date, up to now. So it started in France, and then we had the European project, and then we had some collaboration in UK, some collaboration in India. So it's going to be worldwide. And thanks to you, there will be more about here if I check the participant list. And I think there is someone from India in our colleagues. So maybe you will create a new orrery in India. And so you have to be part of the move. So that's it. I hope I convinced you to be part of this beautiful adventure. And really don't hesitate to write to us. So I don't know, Sarah, if we have time for a question, or how do you see that?
I think one question or two, if someone has questions, I think it will be a good opportunity. This is a wonderful activity, but I'm certain that it's not very easy to do at first. So some people have questions, and if you don't have time to put your questions now, please feel free to send us questions by email. You have our email, or to ask for support to build your own orrery. This is really engaging and an amazing activity.
And we can propose some local trainings if you need. I mean, both in Portugal or in Greece now, or in France. But yeah, we do have people who were trained on how to use it.
In Portugal, is very, very if you came here, must came to my school.
Okay, but Sarah can come to your school.
Yes, we have a Nucleus also organizing. Isadora, where are you from?
Setúbal.
Setúbal. So Nucleus organizing now a training, and Isadora, we will talk to you later on, because I have sent the email, but maybe you haven't seen it, the 2 links that we have, because we are now organizing. I'm not sure if someone else here is from Portugal, but we are organizing some training. So Cel, where are you based? Cel, where are you based? Is also...
I don't speak very well English. I
understand. The training, good news, the training will be in Portuguese.
I'm sorry, but I run in the hour. Eu pensava que era às 5.
Pois.
Começou às 4 e agora
Começou às
depois
4.
voltei ao e-mail e diz Lisboa 4.
Pois.
Peço imensa desculpa.
De onde és?
Braga.
De Braga. So Cell is near my place,
Okay.
so I will then send an email to Cell Isidora, and but not only in Portugal, in other places there will be training. So if you are interested in this activity and in other activities that Astro-Journeys is offering, this was just a glimpse to know
Okay.
how amazing this is, and then we can learn how to actually do it with
Yeah.
students at school. That is the fun part.
Yeah, clearly you need more time than one webinar. It was just
Yeah,
to give you, to motivate you.
exactly.
I want to say one little thing. Yesterday, I have a meeting in my school. In January, we have a day of the school. In 20, no, in the day 20, and I have the club of astronomy. And yesterday, I I talk about this. I have
Okay.
some activities to do, and I talk about a worry, or I don't know the name.
Or
Yesterday, I don't
we
remember
have to
it,
find a name
but
in
yes,
Portuguese.
but I showed the placard I when I was in Greece,
Yeah, yes, of
Yes,
and
course.
Isadora was in the summer school.
yeah, in the
But
summer school.
if you need a big sheet, a big orrery, a
Yes,
human
I
orrery
need.
for your open day,
Yeah.
then I don't know, Sarah, if it's possible for you to send the one that you have.
Yes, we have one that Emmanuel has provided us.
Oh, okay. Okay.
So, yes,
The same that you
20 of
used
January
in
is
Greece.
After
suitable.
I talk with Sarah
Okay.
to do that. Okay.
Yeah.
And
Thank you.
send photos for you.
That would
Yes.
be a good opportunity, Isadora, to do it on the 20th of January, in the day
Yeah,
of school,
20.
right?
Yes.
Okay, let's talk about that then.
Okay.
Wonderful. Thank you. So I hope you will enjoy walking on the planets later on. Thank you. I think we can stop here.
Yeah, thank you so much,
Very
Emmanuel.
much.
Thank you very much.
Thank you very much.
Thank you very much.
And
I stop the recording.
Okay.
Thanks.